Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to begin by taking a look at the night sky for just a couple of nights ago, and we are going to head out to the countryside as well. So I've spoken a lot about the planets in the past couple of videos, simply because the planets are so prominent and interesting at the moment, with not all of them in the sky, but we do have 6 planets in the sky right now, counting Uranus up over there and Neptune down over there. We will technically have 7 planets in the sky in the near future as well. We do have the moon in the sky here as well. Not quite full. We can see there, yeah, 58.8, a little bit past half. We might as well take a closer look. Of course, the moon is the brightest thing we see at night time, followed reasonably closely by Venus. Of course, Venus's brightness is much more comparable to a star than the moon. However, the full moon does provide a lot of light. I've spoken a lot about how much light the full moon creates and how it can obscure things like the Milky Way or the Andromeda Galaxy, even if you are in a dark sky where they should otherwise be visible. And this, the first thing I'm going to talk about, is really only relevant in a dark sky. I don't think this is something you'd really notice in the city. There is a very big difference between a night with the full moon and a moonless night. It's not something we normally notice in the city, but there's a reason why it's mentioned so much in older fiction. You may have noticed, if you've read a lot of older literature, I think in almost any language, people usually make a big deal if it is a moonless night. People will say it, they'll point it out because it matters. A moonless night is so much darker than a night with the full moon. If you don't have any electrical lights to rely on, if you're only relying on light from the sky, or even if you're relying on candles, a candle outside is nowhere near as bright as a modern LED flashlight that can illuminate a whole neighborhood. A night like this is much, much brighter than a night like that. Even that, not exactly a difference between a full moon and a new moon, but just a slightly past full moon and that moon under the horizon makes a huge difference to the amount of darkness. Now, of course, this is a simulation, but if you're in the countryside, it is noticeable. And here on a night of the actual full moon, the ground certainly looks a lot brighter than it does when the moon is out of the sky, or even in a smaller, newer, or older phase. If it's very, very close to a small crescent, it's not going to add as much light to the sky. So on a night of the full moon, the moon is bright enough to cast a shadow. If you've ever been in the countryside on a night with the full moon, if you put your back to the full moon on a clear night with no clouds in a dark enough area of the countryside, you will see your shadow. The full moon is bright enough to cast a shadow. You're just not going to notice it in the city because light pollution, well, a lot of the light that contributes to light pollution is pointing at the ground. Of course, streetlights sort of leaking into the sky is a big part of the problem, but most streetlights are intended to point down. So of course, they're going to outshine the moon. You'll see your shadow based on the streetlights, not on the moon. However, if you are in a dark enough part of the countryside, the moon is bright enough to cast a shadow. And we can see here, Stellarium shows the moon and Venus as a similar size, and Stellarium uses the size of the circle in the sky kind of as a shorthand, as an indicator of how bright, of how illuminated the object is. We'll get that back up to actually full there. So we can see there, -12, that's a very low magnitude, which means it's very, very bright. Venus there is only -4, but nearly 4.5. It would be brighter if it was higher in the sky. The moon and Venus are very different brightnesses. The moon is significantly brighter than Venus, and Venus there at -4.5, really -0.1, -4.1, and Jupiter here at -2.6 down to -2.48, nearly 2.5. It's basically half as bright, Jupiter compared to Venus. Venus is significantly brighter, but it is much, much fainter than the moon. However, thanks to a comment on one of my recent videos, Venus can seemingly cast a shadow as well, and that does make sense to me. Venus is so much brighter than the surrounding sky, especially here where it's far from Jupiter on a night with no moon. Venus being able to cast a shadow does make sense because a night with all of these stars and the glow of the Milky Way, it is perceptibly brighter than a cloudy night. Now, this is true. If you measure the amount of light coming from a sky in a dark sky where there's no light pollution, your light meter, your light detector, will pick up more luxes or lumens or whatever you're using if it's on a clear night compared to a cloudy night. In a city, it's the opposite. The more clouds you have in the sky, the more light pollution is going to be reflected back down at the ground, so the brighter the sky will appear, which does make things a little bit different. But if you're in the countryside on a very clear night, it is much easier to see where you're going, even on a moonless night, compared to a night with clouds in the sky. And I'd be willing to believe, at least, that Venus is significant enough to make a difference. Enough difference to cast a shadow. So that's Venus. The reason I'm bringing this up is partly because it's so difficult to see Venus at its brightest. Figuring out when Venus is going to be at its brightest is a little trickier, mostly because it is a planet closer to the sun than we are. So we can see its brightness here is continuing to climb as it reaches opposition, but it's getting reduced by the air magnitudes as it gets lower in the sky, and of course the glow of the sun itself. Here we are definitely, we're very much past the greatest elongation. So we can see that Venus was climbing there as we got past the greatest elongation. Of course, with most objects, they're going to look their brightest when they're fully illuminated by the sun. And for planets that are further from the sun than we are, that tracks, because they are going to be at their closest to us and fully illuminated by the sun at the same time. For Venus and for Mercury, it's the exact opposite. Venus is further from us when it's fully illuminated by the sun. It's closer to us when it's almost in front of the sun. But the difference that distance makes is significant. So even though a much smaller portion of Venus is illuminated here, we're seeing it as brighter. And as we move away, now I probably will have to adjust for the time of sunset as we go, but as we push Venus to the opposite side of the sun, even though more of it is illuminated, it is significantly further from us. You know, the circles that these objects take around the sky, they're very big, well, ellipses, but going from one side of the sun to the other side of the sun, even for a much closer planet like Venus or Mercury, it's a huge difference. We never get to see Venus at opposition. We don't get to see Venus at what would theoretically be the brightest perspective, which would be if we were on Mercury looking back at Venus. If we were on Mercury looking back at Venus, we would be able to, every now and again, see Venus as fully illuminated in the sky. There are a couple of tricky things with this. So to make it easier on myself, we are going to head out to the Solar System Observer, which will allow us to... Oh, I need to go to the location window. Going out to the Solar System Observer will allow us to look down on the planets from above, and that will let me see when Mercury and Venus are aligned with each other in such a way as that from Mercury's perspective, Venus would be full or at opposition. So here we go. We need to leave planet Earth and head to the Solar System Observer. There we go. There's the sun. We'll zoom out from that because, the sun will dominate our view otherwise. There's Mercury, great, and there is Venus. So by moving through time here, shouldn't be hard. Mercury went invisible, but I have an odd feeling it's pretty much in line with Venus there. So let's see. Of course, we're not going to get... There we go. We're not going to get an eclipse or anything of Venus. Mercury's shadow is not going to be cast on Venus. Unfortunately, Mercury is just too small and so much closer to the sun. You would only get a transit, similar to how we see Venus transiting in front of the sun from here on Earth. If you don't have the right glasses, if you don't have the right equipment, you're just not going to see it. It's not visible to the naked eye. Here, what we need to do is go to Mercury so that we can stand on Mercury and look back at Venus. But unlike the Earth, this is a problem for Mercury and for Venus. The issue of seeing an object at its moment of opposition, it's even more difficult to do for a random location on Mercury than it would be for a random location on the Earth. So this is going to be a little bit tricky. Because Mercury turns around so slowly, I just need to make sure that we're not on the side facing the sun, so I need to be on the opposite side of Mercury. Because Mercury rotates so slowly, because its day is so long, by the time this part of Mercury, which is looking at the sun while Venus is at opposition, by the time Mercury turns around for this side of Mercury to be facing Venus, there's a good chance that it won't be at opposition anymore, because these two planets are A, moving around the sun so quickly, and B, have such incredibly long days compared to all of the other planets in the solar system. The gas giants have very short days. The Earth and Mars's day are pretty similar, and then Venus and Mercury are the weird ones. Their days are a lot more complicated. I have talked about, or spoken about, the day length on Venus and on Mercury in the videos that I dedicated specifically to those planets. They are back on my channel somewhere, but here we go. But I will go over all of the planets again in the near future. So here we are. It looks incredibly dark. Of course, there's no atmosphere. So I should be... Yeah, the atmosphere is already turned off. Cool. That must have happened automatically, which is nice. We can see Venus there, fully illuminated in the sky. And I'll see if I can get a measurement. Yeah, it should be coming past its opposition about there. Roughly, of course, we're on a whole different planet. It's 99.5% illuminated. That's pretty good. And we're seeing it there at magnitude 7. So that leads me to believe, I think I can say with some amount of confidence, that the planet Venus at opposition as viewed from Mercury is not as bright as the full moon when viewed from the Earth. That's something that I have now learned. I didn't know that for sure beforehand, but it does make sense. Venus is so much further from Mercury than the moon is from us, even though it is so large and so close to the sun. Of course, these calculations could also be wrong, but they sound right to me. Anyone who wants to go into the maths of Venus's albedo and the amount of insolation it's receiving, it's interesting maths. It's fun to play around with, but I'm not going to be doing it myself. I would accept if an astronaut or a robot was to ever go to Mercury and perceive its own shadow due to the illumination of Venus at opposition at -7, I would believe that. That would make sense to me. Of course, believing something isn't the same as double checking yourself, but I have no intention of ever going to Mercury daytime or nighttime. So I hope you enjoyed coming along this little investigative journey with me, inspired by a comment on a previous video. So thank you to the commenter. If you did enjoy this video, please do like it. Make sure to subscribe to this YouTube channel if you'd like to see more, and you can head to my website, queebeanscontent.ie, if you'd like to read some of this information. So thank you, and hopefully I'll see you back here next time.